Hello everybody, this is Mr. Ling and just wanted to go over this concept of proportions and cross products because this will come up again a lot, and especially when you get to chemistry. If you take chemistry in high school, this little skill is very useful. So just looking into this real quick. So cross products, this is just saying that when you've got two fractions that are equal, that are equivalent fractions, meaning they are the same, basically the same number, but they might be represented differently. So that's these two here, 3/5 and 6/10. So those are proportional. You can actually figure that out by seeing that you can multiply 3 times 2 to get 6, and you can also multiply 5 times 2 to get 10. So when you check the cross products here, you see that they actually equal the same thing. So that's just taking the top of the left fraction or proportion times the bottom of the right. And you multiply 3 and 10, you get 30. And if you also multiply 6 and 5, you get 30. So that means that they are equivalent. All right. So I've got a problem here. I just want to see if we can solve it together. Let's just take, well, actually, let's take that and let's solve for it now. This is kind of using it or going in the reverse way. So we've got 3/5, and that's proportional to something over 10, but we don't know. We're just going to pretend we don't know what this is. So you have problems like this that are in the exit slip. So you can use that cross product rule to solve for x here. Okay, the way you do it is this: if you just simply do the cross product, I'll just do the x here so you can see we're going to do the cross products, and we're going to line them up down here. Now, rules of equality say I can cross multiply these and put them on either side or the other, as long as I don't put them on the same side, right? Because that wouldn't be right. So just for simplicity's sake, let's do this because we're going to solve for x. So I'm going to put this 5 times x on the left side. All right. So 5 times x, and that's, or you see the number right in front of the variable like that, that just means there's a multiplication sign in there, okay? And that's equal to 3 times 10, which is 30, okay? So now we're going to solve for x. And in order to isolate x, all right, we basically have to, if this is 5 times x, then we have to do something to this on the left here that's going to get rid of the 5. So we know that if we multiply anything by its reciprocal, right? So if we multiply 5, because this is really like saying 5 over 1. If we multiply this by 1 over 5, or in other words, divided by 5, so another way you could look at it, we can, I'm just going to write it this way so we can see that this will work. We have to do the same thing on the other side, right? So we're going to do the same thing over here to make it equal. All right, so multiply both sides by 1 over 5. Now here, these are going to cancel out because 5, you're going to end up with 5 over 5, which is the same thing as 1. So you can just go ahead and cross those off because they're going to cancel. All right, and you're left with x on the left. All right, if we do this, we're going to get 30/5, right? Because 3 times, remember this is like 30 over 1. 30 times 1 is 30, and 1 times 5 is 5. And 30/5 we can simplify because we know that 5 can go into 30 6 times. Because we know 5 times 6 is 30, so this is the same thing as 6. All right? So we got the same fraction, didn't we? So if we go back here, we got the same fraction, 3/5 and 6/10. So the missing number in our case was 6, which we already knew, but I just wanted to show you we could solve for it and find it. All right, so now one last thing. Say if we have a problem like this, which there is in the exit slip. This is different. I'm using different terms here. And actually, I should have used different numbers. Let's do this, because this is going to end up, we can probably tell what that's going to be already, can't we? Well, actually, yeah, it will. So let's use different numbers. Let's say I'm going to take this 2, and I'm going to make this a 4. All right, we're just going to say that that's 4. Actually, it looks probably closer to actual proportions there anyway. All right, so we've got these two rectangles, and we know the sides of 2. Now I'm saying that even though my pictures look pretty not accurate here, this side is the same as this side, and this side is the same as this side. And same thing over here. They're rectangles, so their opposite sides are equal, okay? So we can say the ratio of the height to the length is 4 to 5 on this one, right? And we can say this is equal to, because proportionally these are needing to be the same. Okay, I didn't set this up exactly, but it's like the question in the exit slip. So we're trying to figure out, we're trying to expand this rectangle to this size here where one of the lengths is 10, but we need to keep the proportions the same. So this side, x here, needs to be the same proportion as in this rectangle, okay? So we need to set up equal proportions. So we're going to say 4 to 5 is the same thing as, we have to make sure we put the same things on the same side. So we put the height over the length. So we're going to do the same thing. The height here is x. We don't know what x is, over the length, which is 10. Okay? So now you're going to say this is 5x, whoops, because it's 5 times x, equals 40, right? Because when you cross multiply, you're going to get 5 times x and 4 times 10. And again, I'm putting the x1 on the left. And same thing, we just solve for x here. This time I'm going to divide it by 5. I showed you last time how to multiply by 1/5, but this time we're just going to divide it by 5, and you'll see it's a little easier. So we divide by 5, these are going to cancel. We're going to be left with x on the left. On the right, 45ths. We know that 5 goes into 40. Well, let's see, 5 times 8 is 40, so that would be 8. And there you go. So our answer is 8. So this side right there is equal to 8.